So I got a couple text messages. It sounds like the internet is down on campus.
Yeah, in a lot of places it is. Like
Oh,
the dorms by the academic building and stuff like that.
that's not great. That's a problem. The printer's going crazy, so I hope I didn't accidentally print something. It would be like me to do that. All right. Well, stay safe, everyone. Is this rain supposed to, see now it's sunshiny outside. So weird. What's up, Michigan?
It was pouring when I left the doctor and hailing, and I had to walk like 10 minutes back to my apartment.
Oh, I'm so sorry.
Pretty cool to watch.
What's that?
The hail was pretty cool to watch.
I can't believe it hailed by you. It did not hail here. I do not believe.
It
It
hailed
didn't
a
feel
ton.
great on my skull.
Oh. Nice. I don't know who that was, but that's cool. Okay. Well, let's continue where we left off. We're going to finish the lecture. We don't have very much left to go. And then we are going to be doing some practicing, kind of bring it all together. I'm very much of a doer, so I think it's important to just kind of get a sense as you're doing it. Hold on just one second. Just so you guys know, I'm in class right now. Thank you. Yeah. Okay. So here we are. We were talking about the bottom 5% and what that looks like on our normal curve. Now, if we go here, again, we can talk about percentiles. That's part of what we were sharing earlier. That's the beauty of a Z-score, is that you're able to see where on the normal curve it lies, and then you can translate it into a percentile, which most of us know what percentiles are, and we can speak to them fairly eloquently. So if I am trying to figure out, again, what is a score, for instance, of 680, I could calculate my Z-score, figure out the area under the curve, right? Which for our Z table, it's going to give us from the mean to the score. And then I can add 50% to it, which would give me a total of 97%. Or I can flip it on its head and say that a score of 680 is in the 97th percentile, right? I could say that as well. Or I could say that the score falls in the top 3% of scores in terms of the critical writing. Okay, so again, it allows us to speak to the data rather than just giving a raw score of 680, or again, my example of a 23-inch length baby. What does that mean? It allows us to provide a context and helps people understand what it is we mean. Okay. Similarly, if I found a test score on the SAT of 380, I could figure out the Z-score, which is negative 0.87, and figure out that that is in the lower 20%, okay? So the way I would do that, again, is on our table, the area right here that would fall between the mean and the score on the positive end. So this is a trick question. Let's see. Can you guys figure out what that would be? Or what is this area here in white?
Wait, is it just, it's 30%?
It is 30%. How'd you figure that out, Kyle?
So we have 50% is the left side and then minus 20%. So what leaves is 30.
Right, you're exactly right. So if I were to find the spot from here, 0.87, again, on my, the table that we're talking about, we'll do the right side. So it would tell me that the area between the mean and the score, this area, right, if there was a line right here, would be 30%. And then if I looked at what is this, the dot from here in the tail, right, it'd be this 20%, but then I just flip it to the other side because it's lower than the mean. So that's how I get this. Questions on how I did that? Does that make sense to everyone? Again, because it's symmetrical, you can manipulate it. Okay, so same thing, score of 655 would give me a Z-score of 1.65. I would then be able to figure out that that is the top 5% or that it's at the 95th percentile because the score is higher than 95% of the people in the population or in the sample. Okay. Now let's say the raw score is really close to the actual mean. I go through the exact same calculation, but this gives me a z-score of negative 0.25, which shows me that 40%, the score is in the 40th percentile, right? Or this area between the mean and it, that would be 10%, because again, this half is 50. So another way I can talk about this is that 60% of the sample scored higher than this individual. Okay. This is just another example, talks about birth weight, what that looks like in terms of, oh, what did I just do? So sorry. Birth rate, you can take a look at that on your own. It's just an example that gives you lots of data on here on how you can manipulate, manipulate it. So you have the mean reading z-score, mean math z-score that's distributed throughout, and then you can compare it as you go through. This is another way that's super helpful because now I can see how the z-score evolved over time. You can't really do that. Say their reading score when they were 5 was this, their reading score was this when they were 12, because obviously the scores are it's going to be different tests, right? You can't give the same test to a 5-year-old than you do to a 16-year-old or a 7-year-old, right? So making them all z-scores, you're comparing them within the standard of the sample that receives it. So now you're able to compare even different tests to see how a particular individual is doing. Okay, so that's another advantage. Okay, quick review. This particular chapter is on normal distribution. Make sure you know what that is. Know how you can calculate a z-score and what that looks like. Okay, so next up, I want us to actually do some of this data. Where is Excel? I feel like whenever I go to share my screen, it's never where I want it to be. Just kind of frustrating. Okay, let's go here again. Here's Excel. Okay, let's go back to you guys. Make it big. Here it is. Okay. So I thought it would be helpful for us to do some calculation to get some practice on all of this. So I found this data set. This is an old data set from a while back that looks at purchases. So really, we don't need to worry about any of these things for the purpose of this class. For this example right now, we will look at the unit cost, okay? So in fact, what I'll do is I will highlight this, copy it, and I'm gonna create a new tab. And, oh, sorry, here, don't get mad. Okay, so let's do this, all of us together. This is being recorded so you guys can do it or review it later on. And then I can give you guys access to this data set again so we can practice it on our own. Okay, so what is the first thing I need to do if I'm going to be calculating a z-score?
Find the mean.
Find the mean, right? So that's the first thing I need to do because I'm going to need to utilize that. So based again on what we did last time, right, we can figure out the mean. So the mean equals, what is the mean?
So we can either hit or go highlight all of them and then do your auto sum thing, which is under home or something, and then divide by however many there are, or we could just highlight them all and then look bottom right and then it says the mean.
Right, and then it just gives it to you. So, but overall, the mean is the total scores divided by, right? No, you gave it all, that's fine. By the total number of cases, right? By n, right? So that's total cases. Okay. So as Kyle described, I've got a couple options. I can highlight all of these here, right? I can grab it, go all the way down. Okay. I can go to home. I can move our faces here because they're constantly in the way, and go to auto sum. Okay. Did I end up doing something funky? I mean, it's right here, but 45. No, I think that's fine. Okay. So this is the total. And then I can see how many, so this is my total, and how do I know n? Right? So we can figure out that's 44. There's just one less. So what does that look like?
43.
43. So n equals 43. So my mean then is this 873, right? 873. So I can do this. 873.27 divided by 43, which gives me a mean of 20.31. Okay. Or as we saw last time, you can just highlight them and look down here. There's the total is 873.27. The count or the n is 43, and your average or mean is 20.31. Okay, are we all tracking?
Yep.
Okay, what's the next step?
Next step would be to get the standard deviation.
Okay, and what is the standard deviation?
That is I think I may be mixing it up with what we did last time.
No, that is what we did last time. But we need to know it. So the standard deviation is any given score that is X minus what?
The mean.
Minus the mean, okay?
And then X, and then we need to square it.
Squared, you're exactly right.
And then divide it by n minus 1?
I think just n.
Just n? Okay. Don't know where I'm getting the minus 1.
No, I think that's if you're doing different samples, so that's okay. And then what do we need to do to the whole thing?
Square root it.
Then we need to square root it, right? Okay. I feel like this is not helpful because it's weird writing, but square root. Okay, so the first thing I need to do is take each score, right, and minus it by the mean. So I could do here, again, I'm going to do my columns because that's the easiest, minus, what was my mean?
40. Or sorry, that was n.
I think it's 20.31.
Cheers.
Yeah, 20.31. Okay, so this is a negative number. That's fine, we don't really care. And now we're gonna have it copy this formula all the way down. Okay. So that's this first part, X minus M. Then I need to do what?
Square it.
Square it, got it. So now I want to copy that formula for all of them. Okay. What do I want to do next?
And then take that 234.70 divided by the 43.
Okay, any other thoughts?
Get the sum.
Were you going to say something, Daniel?
For that, bro? Or no?
No. So yeah, we need to get the sum of this entire column, which is written right here, 94,142. So you're on the right track there, Elizabeth, except this is not the last number. We need to add them all up. So this would be
Right.
94,145.53.
So when it's highlighted, it'll just show the sum at the bottom.
It will. Or what I can do, here, let me take this out. I can highlight all of it. Go to home and auto sum. which gives me the same number. Okay, what do I do next?
Wouldn't you take that number and divide it by 43 minus 1?
Yeah, so we're still doing the -1. I feel like did I lead you guys astray with that?
Yeah, the -1 is in the, I think it's in
Oh,
our
oh.
original equation, which is,
The last lab we did for, I believe it was standard deviation, you had -1 at the denominator of that.
Oh, hello, this doesn't help. I'm just pulling up our last.
so that's not, so it's just divided by n. Wonder
That's-
why we did the -1, because that's what I did for the lab, I believe.
Me too.
Here.
Yeah.
I'm having a hard time even finding where I had it in there. Okay. Okay, can you guys still see my Excel sheet?
Yes.
Okay. Okay, so that would be versus oops. Looking at a small number here. Okay, what's the next step? 2241.56. What do I need to do to it?
Square it.
So
Square root.
square root it, right?
Yeah.
Okay, so I'm going to do this, this. I'm going to start typing square root of 2241.56. Which is 47.35. Again, these are the things that give me a little eye twitch. Just two. Ah, there it is. Okay, so I have the information that I need now. From this data set, I know that the mean is 20.31. Get out of there, 12 numbers. And I know that my standard deviation is 47.35. So let's write that somewhere at the top. Mean equals 20.31 and standard deviation equals, I already forgot, 47.35. Okay. What do I need to do next? If I want to calculate a z-score for this price of $19.99, so X equals $19.99. What is Z? So we can pull up our PowerPoint, right? And we know, oh, can you guys see the PowerPoint?
No. We just
Not. That's not helpful. Let's share it again. Okay, this is the formula. So a z-score equals any given number, x, for instance, minus the mean divided by the standard deviation. Okay, let's go back to our Excel spreadsheet now that we know it. So z equals x minus the mean, right, divided by standard deviation. So if I'm doing 19.99, I want to know, where does that fall? What do I do? 1999 minus
20.31.
20.31, okay? I always forget to start doing my formulas accurately here. Let's do another one. Divided by standard deviation, what is that?
47.35.
Yep. And here's my Z. Bless you.
Thank you.
Okay. What two things do you notice about the Z-scores?
It's negative.
Negative. So what does that tell us?
And then it's on the lower half of the mean. So it's
Of the normal curve, right. What else do you notice about it?
It's incredibly small.
Okay, so what does that tell us? Someone else. Kyle's doing all the heavy lifting here, gang.
It would be close to the middle.
Exactly, right? So with the z-score, we know that the mean is what?
0 or 1.
0.
Yes.
Yeah, the z-mean is 0. And then the x that I chose at random, because it was in my eyesight, was 19.99. Is that close to our actual mean?
Yes.
Very close. So it makes sense that this number would be very close to 0. And it makes sense that it would be negative, right? Because this x is smaller than the mean. Okay. I'm going to pick on one of you now. Savannah. Pick a number on the unit cost, any number. Uh-oh. Can you see them, Savannah?
Yeah, can you hear me?
Oh gosh, of course. Sorry. Yes, go ahead.
Okay, sorry. It takes so long to unmute. But $8.99.
$8.99?
Yeah.
Okay. So $8.99 is my X. What do I do next?
And then
This is anybody, not just Savannah, but
well, minus the mean. So
minus the mean, which is 20.31. And then
the standard deviation.
divided by the standard deviation, which is 47.35. Let's see what we get. Negative 0.2, let's fix these silly numbers here. 0.24. Okay, what does that tell us?
On the left side of the distribution again, but a little further away from the mean than the last one.
Okay, yeah. So again, this number falls to the left of the mean, right? And it's because it is smaller, 8.99 is smaller than the mean of 20.31, but it's still quite close to 0. So now we've had two numbers, 8.99 and we had 19.99. This is kind of more advanced question, but I know you guys can handle it. So both of these values here, let me make this a little nicer. They're quite close to 0, even though these two numbers are not all that close to one another. What might that tell you about the distribution or the variance that we have found in our mean, in our sample?
Would that mean it's not very big?
That the mean is not very big, is that what you said?
That the variance isn't? Because like,
It's actually the other way around. The variance is very, very large. Like it's very, very large. And we have, in fact, if we were to calculate our range, let's do that. Do you guys remember how to calculate range?
Highest minus lowest.
Highest minus lowest. Okay, so look through here. What is the lowest number?
$1.29.
$1.29. What is the highest number?
19.99 or what? Oh, 125. Whoops. 275.
$2.75. Okay. So we have a very, very large range. Now, in fact, if we were to plug these in, the bulk of them, now I kind of want, okay, I gotta do this. We're gonna totally geek it out here. Okay, we're gonna do this. Oh, I've gotten 2 texts from students who have said now that they have no power in their house. Sad face. Okay, I want to see, to get an eyeball view of mode and median and just general distribution, I can actually sort my data. If I can find the sorting button, there it is. Continue with the current selection, column F, and I want from smallest to largest. Okay. It's downpouring here now again. So you can see the lowest is 129, highest is 275. But really, our mean was what? 20.31, right? How many of our values are above the mean?
4.
4.
So is that
Okay.
a positive skew?
Well, yes, because it's skewed. So again, the way I would describe it, okay, would be like this, right? So we have more values at the lower end of our distribution, very few over here. This makes like a sideways P. Yep. So if I do this, these 4 are higher than my mean. The rest are all lower. So this is a skewed sample, which greatly impacted the mean, right? This may be a better one that the median would have been a better representation, but we cannot use the median to calculate a z-score, okay? So in order for us to have a great amount of variability, right, the standard deviation is 47. That tells us it's huge, right? So between each, that's to account for those really big outliers. So let's use now the smallest value, 1.29. Let's see what we get with that, okay? So again, how do I do that? 1.29 minus what?
20.31 divided by 47.35.
Got it. Hey, what do we get here? Still a very small number that's approaching really 0 again. Now let's look.
Question really quick.
Oh, yeah.
So we did the smallest number there and it's still close to 0.
Yeah.
I mean, is it all relative to the situation? So like if it were 1, it's still, I mean, it's still considered fairly close, but it's kind of far away because the number given.
So again, it's based on 2 factors, right? If we know that the mean is at 0 and the standard deviation is 1, but my standard deviation here, look, it's 47. So if you think about it, again, if I was graphing it, my mean would be 20 minus 47 would be 1 standard deviation, which would be a negative number, right? That wouldn't make sense. So we're kind of hitting a ceiling on this side. It's on the other side now that we're going to be able to see it. So let's see it out. What if I pick my largest value, which is what?
275.
275 minus my mean, okay, divided by 47.35. Here we go. So we see here my standard deviation is, or my z-score is very high, 5.38. And again, that score falls below, right? That would be at the 0.99th percentile. It's so far off to the right because this is a sample that has so much variability. There's so much variance in it. Okay, takeaway points from today that you guys need to be familiar with as we go into the exam and future weeks. Can you calculate the mean if given a data set? Can you calculate the standard deviation step by step as we just did in this class right now? Can you then use the Z formula to figure out what a Z-score is and then infer what it means about the sample? Those are really the main goals. We're going to do more examples of these next week because it keeps on building on one another. But this is like biggest foundation. Questions I can answer about all of this?
Is there a highest number you can reach for a z-score? Like, is there a cap?
Yes, and I would say like anything above 5 is very, I mean, it's just incrementally low. I guess it would be infinity to be clear because it never actually hits the normal curve never hits the x-axis, right? It always tails out further and further, but it's infinitely small. Yes. Yeah, and in cases where you have outliers, like in this distribution, you might get some much higher scores on either end.
Awesome.
So
Okay.
the book has information about how to relate it, or your final point of what you said, right?
How to, tell me more about that, Elizabeth. I'm not sure.
I guess I don't know.
Are you talking about how in the book we have z-scores that indicate percentages and stuff?
Maybe.
Like the thing about the appendix?
Now I'll have to think about it for next time. I'll have to
Okay.
formulate my question better.
Okay. And again, for the exam, I'm going to be providing you guys that appendix for you guys to look through so that you can know exactly what percentages goes under, because that's going to be part of the questions we ask. Okay. That's all I've got for you guys today. This is a shorter class.
Alrighty.
Okay.
Thank
Have
you.
What was
And,
that?
I said thank you, and everyone stay dry.
I know. Stay dry. Keep power. Go get soup. Seems like a soup day. All right. Talk to you guys later.
Bye.
Yeah.
Bye.